Hello, and welcome to this session on building agentic AI applications with the Autogen framework. My name is Nitya Narasimhan. I'm a senior AI advocate on the developer relations team at Microsoft. And I'm joined today by Eric. Hi, Eric.
Hi, Nitya. My name is Eric, and I'm a senior researcher at Microsoft Research. I'm also a core maintainer of the Autogen project.
And this talk is also featuring a third member of the Autogen team, Jingya Chen. You'll see her a little bit later. So let's get started with what we want to talk about today. Our goal is really to kind of get you familiar with this notion of agentic AI applications. So if you are a developer, you've probably heard the term agentic AI in the context of generative AI applications. By the end of this talk, you should be able to understand what agentic AI applications are. We'll introduce the Autogen framework. We'll do a couple of demos. In the first, you'll get a sense of how you can go exploring the Autogen framework without code using the Autogen Studio tool. Then we'll dive into a code-first approach where you will be able to see complex conversational patterns and learn how to build this with the Autogen Python libraries. And last but not least, we have a surprise, so stay through to the end, where you'll get a sneak preview of some upcoming features and design from the Autogen team. But let's get started with an introduction to agentic AI. So you might be wondering, what exactly is that? So to set the stage, let's talk about generative AI first. We know generative AI applications are taking the world by storm. We are seeing them in everything, in enterprise and consumer space. We're building applications, and the pace of innovation is exhausting. Building solutions with it can be challenging. We're using large language models, not custom models anymore. And these are trained on massive quantities of data. So when we use this, we also need to think about things like prompt engineering. Our applications are now using conversational interactions that are driven by natural language. That's a whole new set of challenges because our prior tools are really kind of used to more discrete request-response style patterns. Last but not least, we're going to find there's a ton of different things we need to do to orchestrate these end-to-end workflows from ideation all the way to operationalization. The problem with, or opportunity and problem with generative AI applications is that chat-based experiences require humans in the loop. It's a human user that puts in the prompt, and it's a human user that gives the instructions that ask the model to kind of build or execute a task for them. And that's a challenge when we want to automate and scale these applications. This is where agentic AI application development can help. If you're familiar with agent applications, not AI, but just agentic applications, traditionally, what it consists of is autonomous agents. Agents that are capable of planning and executing decisions on their own with minimal user involvement. They do this by knowing what task to run and what tools to use to execute particular tasks so they can do this asynchronously and autonomously and then return the executed results to the user. But when we think about generative AI, we now also have to think about conversational workflows. Not only do we have to do this, we need to coordinate these actions across the agents, the user, and the environment. And this requires new tools and practices. That mindset is what helped us kind of get towards looking at Autogen. So when you think about agentic AI with frameworks like Autogen, you really think about three things. First, conversational agents. A conversational agent is one that can communicate with other agents and with the user and the environment using natural language. It should be configurable, so it can use a large language model. It should be customizable, so we can engineer the prompts. And it should be chainable, so it can plan and execute in collaboration with others. Execution workflows are also going to get interesting because now this agent needs to look at natural language and infer what skill it needs to use. It then needs to execute the relevant tool, but it needs to do it responsibly because we want to make sure that that code is executed in a safe way. Last but not least, there are many ways in which we can have conversational patterns, agent to user, agent to environment. And this requires new best practices and design patterns that help you figure out how to take a complex application use case and build it out with agents. So that brings me to the next step of like, this is all great, but I'm a developer. How do I actually kind of translate this abstract concept into practice? And this is where I reached out to my friend Eric, who's on the Autogen team. Autogen is a framework for building agentic AI apps. So Eric offered to come and tell us a little bit about Autogen. Hey, Eric, you want to tell me a little bit about what Autogen framework does?
Yes, so Autogen framework provides you with two things. First, it gives you a very customizable way to define your agent. The agent can be backed by a large language model. It can be backed by tools or code executor, and also can be backed by a human user. The second thing that Autogen provide is how to make the agent talk to each other. Essentially, we provide the conversation patterns that allow you to orchestrate multiple agents conversation. And the Autogen framework is an open source project. It contains a lot of notebooks to get you started. It also has research projects going on in the open source code base. And so that's these research projects kind of focus on how to automate the orchestration and also how to discover new design, new conversation patterns. So the next, so in this example, we show a simple two-agent setup. We have two agents here. One is the assistant agent. The other one is user proxy agent. So the assistant agent represents a large language model, where the user proxy agent represents a human user. So the user proxy agent in this case start a conversation with the assistant. So the user proxy is a sender in this conversation, and the assistant is a receiver. So the task here is to simply plot a stock price chart comparing NVIDIA and Tesla stocks. So one thing to take a look at here is that you can see how simple it is to design to create the agents, and how simple it is to just have them talk to each other with a single function call.
Yeah, and I really like this example because it kind of gives us the fundamental building block of building agent-based applications in Autogen, which is to understand that you just need to configure your large language model, whatever you want to use. Then you need to decide what agents you want to have communicate to get the task done. And this particular example I like because it also gave me an intuitive sense of how your agent can execute tasks in that environment. And I believe this was for a local execution example, but I've seen that your documentation also shows you how to execute it in Docker for a much safer environment for execution. Was that right?
Yes.
Awesome. So where do I go next? I think one of the things I noticed here was at the end, you mentioned that there's both a no-code and a code-first approach. And I'm starting new in Autogen. You're the expert. So I think you were telling me I should get started by looking at no-code. Is that right?
Yeah, that's right. So in fact, we also built a low-code environment. It's called Autogen Studio. It provides developers a way to get started with Autogen without writing any code. And the cool thing is that it actually maps very neatly to the basic concepts of Autogen. And so you can learn about Autogen without knowing how to use the Python SDK first.
And
so
go ahead.
Yeah. So in the Autogen Studio, you can define the skills, which are reusable functions and tools that the agent can use. You can also kind of define the models that are used by the agents. Moreover, you can also define the orchestration of multiple agent workflows. So in the notebooks, you can create a new session, and in the session, you can test and validate your agent workflows. Not last but not least, you can publish your workflow sessions into a gallery so that you can revisit those sessions later and share it to your coworkers and friends.
Yeah, and so once Eric told me about this, I knew I had to go try it out. Before I go dive into the demo, let me actually take a minute to share with you the blog post that you must read. It's at the bottom of those slides. And also shout out to 𝗏𝗏𝗍𝗍, who's the lead on building Autogen Studio. If you go read this blog post, this was published in December, it'll give you a really good sense of the different elements of Studio. But I also want to tell you that this is a tool that is actively in development. What that means is by the time you see this, there might be a newer version with newer features and lots more coming. So stay tuned. But let me get back to what Eric just said, and let's walk through this tool and kind of intuitively, if you're a developer, you want to intuitively build your sense for how to build an agentic app, let's figure out what that is. So to get started, I actually run this in Codespaces because I love Codespaces. But you can also just run this by setting up the environment. All you need to do is install Autogen Studio. Autogen Studio is a Python library. It's currently, I think, around v0.056, so very, very early stages. But it's a great way for you to intuitively explore this in your local development environment. So pip install Autogen Studio, and then validate your install by doing Autogen Studio version, and it'll tell you what version you're running. Before you get started, I'm actually running it right now, as you can see, and we'll look at that in a minute. But before you get started, remember that in order for you to build an agentic AI app, you need an LLM. You need a large language model. And so you need to actually have some provider in mind. By default, Autogen has a ton of examples using OpenAI and Azure OpenAI, but it also has blog posts and samples that show you how to use local models and servers. Use Ollama or anything you like, or use an open source model from Hugging Face. So over here, what I've done is I've actually set up my Autogen Studio to use an OpenAI key. And just a handy tip, if you're using code spaces like I am, you can actually just set up your OpenAI key, and you can see I've set it up for Azure and for OpenAI. Set it up one time in GitHub code spaces, and then just associate it with every code space you want to use, and you never have to remember that again, and you'll never leak your keys. So here we are. I've set up my OpenAI key. I'm all ready to go. So let's get started with Autogen. So you'll notice here that I'm actually running Autogen Studio. It's Autogen Studio UI. I've given it a particular port. And when I do this within code spaces, it'll actually launch a tab and let me open it up in a new tab. This is what Autogen Studio looks like. So we're going to take a quick tour, and I'm going to keep in mind the different things Eric mentioned. So let's start with skills, right? First, I want to kind of have you look at the big picture and see that this version, which is slightly older, there's a newer version where the gallery is not as visible, but this version has 3 tabs, a build tab. And a build tab is where you would go as a developer to actually build up the components of your agent application. The playground is where you would then activate a session, attach a workflow with a particular task, and execute it. So you can test it out interactively in your local environment, and then use that as a way to iterate on your different components, prompts, models, etc. Last but not least, this version has a gallery feature, where what you can do is when you finish building something and you've tried the session out, you can publish it to a local gallery. I found this super useful as a way to go back and see how my application evolved version by version. But let's start with a playground. So the playground is where you would start off a new session. I've done a few that I want us to look at, but just to kind of give you a sense of how this works, we can start by seeing what a new session does. When you start up a new session, it's going to give you an option to begin with an agent workflow. You have to have an agent workflow. Now, this particular version has 2 agent workflow templates available by default. If you were to go ahead and create a new workflow, that would show up here as well. So over here, I can say, go ahead and give me a general agent workflow, and I can go ahead and create it. When I do that, you will see that this new one is just created here as a general agent workflow. I like to rename these things just so I remember. So I'm going to call it live demo, just so we remember which one this is. And now we can kind of take a look at what this looks like. Okay. Let's go. All right. So once I've renamed the session, I can go ahead and look inside it to see what's happening. Now, this is just a general agent workflow. I can go into the build, go into workflows, and understand what this general agent workflow does. You can see that it has a user proxy agent. A user proxy agent is the one that represents the user in these agentic applications. In other words, I tell it what I would have said, the prompt I would have put in, and I can walk away and it can execute it on its own. The receiver of the message in the conversation is a primary assistant. And you can see in here that the primary assistant is set up to have 2 different tasks. It can find papers with archive, and it can generate images. It has a system message that tells you what it's capable of doing. We'll look at that in just a minute. It's provisioned with a GPT-4 model. The temperature is set, and it's set up to say never have human input. In other words, this particular agent is told, you can't interrupt the user and ask for any decisions. You got to take care of everything yourself. So with this in mind, we now have this particular general workflow, and it's used for general purpose tasks. Notice that I just set it up here. So what can I do? I can pretty much do anything. So let's go in there and say, hey, what do I want this agent to do? I want this agent to kind of, let's say, find the latest, or let's do this way. Summarize the Taylor Swift biography page on Wikipedia in one paragraph. So let's see what happens. When I do this, I have not told it how to do it. I have not told it what model to use, what the prompt should be, nothing. I've given it a task as a user. The agent is going off and working on it. And this is the value of autonomous agents. If we look under the covers, this agent, and I can actually switch into my into my CLI over here, because you can see what it's doing. And once it's done there, we can go back and look at it. So I've gone ahead and said, please summarize the Taylor Swift biography page. The primary assistant, the user proxy, I'm the one who submitted it. The primary assistant says, great, I got it figured out. To summarize this, I will first need to, and notice how it's beginning to plan its actions. I will need to fetch the content. I will use Python to scrape the Wikipedia page. I will summarize it, and then I will send that answer to you. So I need to start by first fetching that content. It goes ahead, figures out the right Python packages to use, executes it. It has a fetch Wikipedia intro Python code that it's written, executes it, and then retrieves that information. So if I go in here, that agent is still working on the task. We'll come back and check on it. Meanwhile, let's go and see. So notice that it figured out what task to write, wrote the code, ran the script, and then now it has the output. It says there was no output that says the script did not successfully extract the text. I need to go fix this. So it goes ahead and it actually tries to go fix the issues that it found. And now it's able to succeed and get the output. No interruption or intervention from me whatsoever. Once it's done, it takes that summary, posts it to the page, and puts a terminate message to say, my task here is done. And if I look at this now, you will see that in the agent, there we go. It's passed out the summary of what I asked for, terminated it, and I can now walk through and see the entire flow of actions that it took. Isn't this amazing? I had to do absolutely nothing other than submit a prompt, but it was able to figure out or infer the right tools, execute them, get the responses back, put it together, and deliver the response to me. And anytime it saw issues in the middle, it took care of them. So let's now look at the next thing. We've looked at skills. Oh, now we're going to look under the covers at what the different components are. Skills, models, agents, and workflows. Oh, we're doing the demo right now anyway. So let's go back and look at the studio. So if I go into the build tab, first, let's talk about skills. Skills are nothing but Python functions that an agent can use to solve tasks. If you're familiar with OpenAI and you're familiar with function calling, think about this very similar to how you would write a function for function calling. Here, for example, is a skill that helps you generate images. It defines what that method is, gives you a description of what it does, tells you what the arguments are, and writes the code that would actually process that incoming request and send back a response. These skills are reusable functions. Next, I can go in and create a new skill, and when I do, it gives me a boilerplate that I can use and that I can then change, save, and I can create myself new skills. Next, models. Models are what you're going to use when you configure your agent that'll actually process that prompt. So over here, you can go ahead and use OpenAI models, and you can see that there's an example for a GPT-4 model from Azure OpenAI, one for GPT-4 from OpenAI. There's even models that you can use that are from Hugging Face using local servers. You can go ahead and create a new model. Once you have a model in your studio, you can attach it to an agent when you construct it. Agents. There are two examples you start with. The user proxy agent is the one that stands in for the user in these conversational patterns. The primary agent is the one that actually executes the task. We already took a look at it, but you can see how an agent is created. You can go through this and create your own. Last but not least, workflows. So what does a workflow do? So far, you have skills where you can define all the things that will help the agent execute tasks and talk to various environment or service endpoints. You know models that's going to actually process your inputs. And you know the agent is the entity that's going to put all this together. But a workflow is when you have a task that needs to occur, that needs to have these agents work together. And we saw two examples here. But I'm going to come back to the second one in just a minute. Let me point out that the playground, every single workflow you run, you can go back and look at this. You remember we saw an archive agent? Here is me running a very simple prompt with the default agent saying, find me a paper in Autogen and summarize it in one paragraph with a list of 3 benefits. I can go back at any point and see how it actually broke this down. It'll tell you the steps it took. It'll tell you any issues it encountered, and then it'll give you the result. Now, once I've got this agent working, I can simply go ahead and publish it to the gallery, and it will show up here as something that was previously published and tried by me. At this point, I'm going to leave you with one last example. So if I look at the slides, we now know what skills are. We know what models are. We know what agents and workflows are. We also created a session and published it. So what else do I need to talk about? Well, when I looked at the example that I showed you, it was for a really simple agent with user interaction. So as the user said, I want you to do a task, a single agent got it done. But what if that was a complex task and I needed specialized agents? It's possible I might have fine-tuned large language models that are good at specific tasks that I can create agents on that will do that particular thing really well, rather than having a uber general purpose agent. How could I do that? So if you want to play with that, go ahead into the Build tab and look at the travel agent group chat workflow. I'm going to look at that really quickly and then walk you through the example that I've already run so you see that in action. So over here, you can see that it's basically saying the user proxy, the one that gives the request. But now you have a group chat manager. And this is one of the important concepts when you're thinking about multi-agent applications. Not only does every agent have the ability to take its input and figure out or infer what tools it needs, what tasks it should run, how it should approach prompting the model, but when you have multiple agents that need to work together, you have things like planners, managers that get together. So over here, this group chat manager says, I have 4 agents. I'm going to book a trip to Spain. So I have a travel planner, an assistant, a local assistant agent, a language assistant agent, and each of them will go specialize that task, come back to me with responses, and I will put them together. So I'm going to really quickly just look at the one I've already run so you can get a sense of how that works. And then I want to tell you something interesting, which Eric's going to talk about. So here's what happens when I say, hey, please plan me a 4-day trip to Spain with stops in Madrid and Barcelona. I actually did this. And then I'm vegetarian, so I'm saying, please identify cultural places to visit and vegetarian food options to try. And when we look at this, you'll see that immediately the group chat manager says, okay, I think I'm going to need the help from a local assistant and a language assistant, gives them each the task with this prompt and says, come back to me with your responses. They come back with their responses. It then puts it together, and you will see that it got travel assistance from the travel agent, and it got language assistance from the language agents, and put it together and gave it to you. But if you want to see what happened under the covers, expand on the agent message, and you will literally see how each agent went through, processed its bit of the task, gave the results back to the group manager, and it published them. With that in mind, that's a really rapid review of Autogen Studio. And I'm not even, it's not on the tip of the iceberg. So definitely go check out the blog post and try it yourself. But you'll notice that this is not giving me complex conversation patterns. I can't see all the capabilities of Autogen, and Autogen has so many more things. So I asked Eric, hey, is there a better way? And Eric said, there's an SDK. So Eric, do you want to take it away and tell us a little bit about how we build code first on Autogen?
Yeah, sure. So let's take a look into the SDK. We have already talked about the basic concept of Autogen using the Autogen Studio. So there are models, agents, skills, and workflows. We have also built a mini application using Autogen Studio. So now let's move to the concept of conversation patterns, which are building blocks of the multi-agent workflows. And we can dive into these concepts using the Autogen Python SDK. So what are conversation patterns? Conversation patterns are the basic building blocks for multi-agent workflows. They define how agents in a workflow communicate and pass messages to each other. Different conversation patterns are suitable for different types of workflows, but you can also concatenate and nest them to create more complex ones. So Autogen Studio currently provides 4 conversation patterns. 2-agent chat is the most basic conversation pattern in which the 2 agents work on the same thread of conversation. Sequential chat is a sequence of 2-agent chats. Each chat has its own thread. It provides a carryover mechanism to pass information from one conversation thread to the next. Group chat provides a way to set for a set of agents to work on the same conversation thread. Nested chat packages a sequence of conversation thread into a single agent to add a system 2-like thinking process into its response generation. So let's focus on the 2-agent chat and group chat in this video. Let's start with the simplest conversation pattern 2-agent chat. We can take a look at the diagram. The 2-agent chat is initialized with an input message. So this could be a message from the user along with some other parameters on how to run the chat. In this chat, the 2-agent takes turns to contribute to the same conversation thread. Lastly, the conversation thread is passed to a summarizer to produce a chat result object. So this code illustrates an example of 2-agent chat in which an assistant agent generates code blocks using large language model GPT-4 The executor agent runs the code and generates reply using the code execution result. So for safety, code execution actually happens inside a Docker container to avoid direct impact to the host platform. So the code executor writes each code block to a file and executes it inside a Docker container, and then reads the output to formulate an agent response. So 2-agent chat is very useful for solving simple tasks with a limited goal that can be achieved with a few iterations between the 2 agents. So when you have more and more complex tasks, however, the 2-agent chats will start to lose track of the process of the progress and get confused. So when the 2-agent chat setup is no longer cut it, you can try a group chat. A group chat has a set of participant agents and a group chat manager agent. All agents in the group chat works together on the same thread of conversation, much like a group chat in your favorite message app like Teams or Slack. The group chat manager selects the next agent to speak. The select agent generates a response and the message is broadcasted to every other agent in the group chat. Let's take a look at the code. First, you might have noticed that we put the programming assistant and programming executor agent from the previous 2-agent chat into the group chat. Second, we also added a research assistant and research tool agent to perform research with a web search tool. Third, this is the most important one. We added planner agent. So the planner agent has a system message that says, you're a planner for complex tasks. You come up with the plan and assign subtasks to different agents. You'll also check for the completion of the task and provide feedback to the agents. So this system prompt gives the planner the capability to decompose a complex task into multiple subtasks. And this allows it to guide other agents to complete the subtask and check for the progress. Last but not least, we also added an admin agent to the mix to allow human feedback when necessary. So when your tasks get even more complex beyond a single group chat that can handle, you can bring in nested chats to implement a participant agent in the group chat. You can also further nest a group chat into it, and so on. So this is the power of conversation patterns. They can be composed to create new ones that are capable of handling more complex tasks. So this composability allows you, the application developer, to encode your domain knowledge into the building of your multi-agent workflows and differentiate your products from others. Now, given that, let's jump into some code. So in this notebooks, I set it up with Autogen library and also install a small search web search tool library. So first, we import the external dependencies, and then we set up our large language models, which is a GPT-4 This is the only one we're using for this notebook. And in this is interesting. So we're gonna start with a research team. So the research team in this case contains 2 agents. One is the research assistant agent, and another one is a tool agent. So the research assistant agent is set up a system prompt to teach us how to use the research tool. the research tool is agent is assigned with is registered with a research tool function, which simply performs a web search to find raw information from the web. The register function essentially register the search tool to the executor, which is the research tool agent, and to the caller, which is the research assistant agent. So in this setup, you can see the research assistant is going to call the search tool, and the research tool agent is going to execute the search tool. So let's execute this cells. And now we can test our research team. We test the research team with a simple question: what is the address of the building hosting Microsoft Research in Redmond? And you can see that we have a reflection with LLM setting for the summary, so that once the chat completes between the two agents, it is going to use the history to summarize and generate a response for this message. So you can see the research assistant, given the input question, it first calls the search tool with the query Microsoft Research Redmond address. And the search tool returns the result in raw text. And the research assistant is able to read the raw text and summarize and extract the information from the search result. And the chat terminates, and we can take a look at the result summary. It says the address of the building hosting Microsoft Research Redmond is Microsoft Building 99. It's at 14820 Northeast 36th Street. So this is the result for the chat. So we have tested our research team. Let's move on to our programming team. The programming team, again, is a setup of two-agent chat. So in the programming team, we have a programming assistant agent. So the programming assistant agent is taught how to use code to solve problems. So the code is always generated inside a markdown blocks with a Python language specified. And then in this interesting, one thing to pay attention to is that we use a local command line executor in this notebook, but in production, you do want to use a Docker-based command line executor so that you can provide a layer of safety on top of your host platforms. The program executor agent, again, is responsible for executing the code generated by the assistant agent and is assigned with a code executor setting, so that this code executor is corresponding to the local command line code executor. So let's run this, and we can test our program. And the task we assign to this programming team is simply say a very famous math problems about rabbits and chickens. There are some rabbits and chickens in a barn, and there are 532 legs and 172 heads. How many rabbits and chickens are there? This requires the model to know how to use a simple SymPy library to solve for equations. As you can see, it generates a code block in Python and uses a SymPy library to formulate the equation for the heads and legs, and it calls a solve function to generate the answer. So we just talked about the programming team. Let's move on to the group chat. And here we use the programming team and the research team to assemble a group chat and also add a planner agent and admin agent. The planner agent, as we have seen before, is able to decompose the tasks and check, provide feedbacks and check progress. It's important to note that we also add descriptions for each of the agents so that the group chat managers know which agent to call next. Mm-hmm. Now we set up the group chat. In the group chat, we put all the agents in the group chat, adding the admins, and add a transitions. So the transitions is basically a rule-based transition rules that says, given the current speaker, what are the allowed next speakers? Now we have set up the group chat with the group chat manager containing the group chat. And let's have the admin agent initiate chat with the group chat manager with a new task. Notice that task is different from the task that we have used from before. The task is that found top 5 countries by GDP per capita and create a plot and save it to a file. So you can see it's getting to work, and the planner agents first come up with a plan, decompose the task into subtasks, and assign each task to an agent in the group chat. And then the research assistant agent calls the tools to search for what are the top countries by GDP per capita. And then given the result from the research tool agent, research assistant agent gets the result for the first subtask, the top 5 countries. And then the chat manager, the planner said, okay, now it's your turn for programming assistant agent to generate a code to create a visualization. So the programming assistant agent wrote the code using matplotlib, and it's going to be executed by the programmer executor agent, and it generate a figure. The figure is saved here. And then we can go here to take a look at the result, and you can see the visualization is generated. Okay, so this is the code. So let's take a look at some of the what's going to happen next for Autogen and Autogen Studio. So for Autogen Studio, we are working on a redesign, and this allows us to give a much more streamlined workflow creation with drag and drop interactions. We're also going to add a lot more conversation pattern to more than the group chat that we have in Autogen Studio currently. And we allow users to design their own conversation patterns using the canvas. We're also going to double down on a community-driven learning by engaging with the gallery to share and learn different creations created by the Autogen Studio. So let's take a look at the video that Jingya created to show what's next for Autogen Studio. And we would like to get your feedback on our next step.
Hi everyone, I will give you a brief walkthrough of the upcoming Autogen Studio experience. In developing this new experience, we focused on 3 key design principles. First, we aim to reduce complexity and enhance productivity, allowing users to accomplish more with less effort and time. Second, we're empowering users with a flexible and intuitive interface, enabling them to create diverse conversation patterns easily. Third, we're integrating testing and experimentation features, and we encourage active community participation in the Autogen gallery. Next, let's look into an example of workflow creation experience step by step. The first thing is the simplified entry and start from examples. This is a dashboard of the build section for a first-time user. Here you can see that there are 4 main options to build something new. You can build a workflow, which is a multi-agent system. You can also choose to build an agent first and then contribute it to a workflow later. For first-time users, they can start with an example we provided below rather than build something from scratch. For the returning users, besides the entries of building new things, they are able to find all the things they have created before using the Autogen Studio, including workflows, agents, skills, or models. And you can still see some of the example on the right if you need. Next, let's look into what would happen if you choose to build a new workflow. You will start with a very simple setting of a workflow by giving it a name and a description. In the advanced settings, you can come in and select a default model to apply across the entire agent workflow. And if you want to use some existing patterns, you could choose one template to start with. For example, the group chat workflow, and you will enter the canvas with a group chat template to continue. Next, let's see how we achieve quick customization and reusability in this canvas. On the left-hand side, you have a library with all the components to create a comprehensive workflow, including the agent, skills, and models. If you create a new agent, you can easily drag and drop an existing agent into the containers. For example, if you drag the group chat agent, it will add this group of agents into the canvas for you to continue. You can also drag an existing skills or models under each agent, or create new skills and models easily from here. And when you select an individual agent, then on the right-hand side, you will get all the individual settings of that agent. So you can go in and tweak all the settings in this scenario. You can also select individual model to configure or an individual skill to edit. Next, let's see how would you test the workflow you just created. When you click on the test button in the right bottom corner, a test panel opens up where you can quickly test out and chat with this workflow without waiting to go to the playground to test. And when you hit the debug insights, another panel opens up aside where you could view all the agent messages and how they interact, so as to observe what's happening and what's going wrong. In the end, I would love to show you the new playground and gallery of Autogen Studio. As the end user in the playground, you could use all the workflow you have created or try out some other popular workflows from the community. You could initiate many sessions as you want using different workflows. And even more, we would have this beautiful gallery collecting all the ideas from the community, including workflows, agents, skills, and even sessions, so people could share, learn, and collaborate with each other from here. So this is a brief intro of what you can expect from Autogen Studio in the coming months. Stay tuned for updates, and we warmly invite you to contribute to this community. Thank you.
Wow, that was awesome. I cannot wait to see that new design. But I think that brings us to the end of this session. Thank you so much for having us. And before we kind of wrap up, just a quick summary of what we covered. Hopefully, if we did our jobs right, you now know what agentic AI applications are, what the Autogen framework does. You got a sense of how the Autogen Studio works for low-code, no-code development. You got a sense of how you can use the Autogen SDK for a code-first approach to building multi-agent collaborative applications. And you got a sneak peek at the upcoming design. So, Eric, where should they go if they want to contribute or converse with the community?
So on the top, the bottom left corner, you can see we have the link to the Autogen roadmaps. If you want to contribute to the project, please take a look at the roadmaps. Also, we welcome you to join the very vibrant Autogen community on Discord. It already has 20,000 members and daily active members about 2,000. So a lot of people are asking questions and getting help on how to use Autogen, and also explore ideas and potentially find new collaborators to work on your projects using Autogen.
We can't wait to see what you'll build. And do come share your creations on Discord or on the Autogen gallery. Thank you and have fun at Build.
Thank you. Can't wait to see what you're going to build with Autogen.